Well, thank you for coming today. Good evening. I'm Michael Hiven. I'm the director here at the Pearson Library. Thanks for joining us for tonight's presentation, Sustainable Salting Practices and Local Water Quality, hosted by the Lewis Creek Association, the Shelburne Natural Resources Conservation Council, and the Pearson Library. During winter, road salt plays an important role, as we all know, in keeping our roads, sidewalks, and parking lots safe. But as we've learned in recent years, the salt that helps keep salt that helps us travel safely can also make its way into our streams and groundwater, impacting water quality, harming roadside vegetation, compacting soils, and even allowing heavy metals to move through soil more easily, potentially impacting drinking water supplies. Encouraging news is that there are practical steps communities, contractors, and individuals can take to reduce salt use while maintaining safety. Tonight's presentation will explore those solutions and share insights from both research and local monitoring efforts. So we're pleased to welcome Kate Kelly, who will be sharing results from recent water quality sampling for chloride in local streams. Kate is a conservation biologist who grew up right here in Shelburne and has a deep passion for Vermont's natural ecosystems. She currently serves as program manager for the Lewis Creek Association, where she works closely with landowners and communities to protect water quality and wildlife habitat. In addition to her work with the association, Kate helps coordinate the Vermont Reptile and Amphibian Atlas, drawing on field experience studying reptiles and amphibians here in Vermont, as well as Wyoming, Missouri, and West Virginia. She holds a bachelor's degree from Middlebury College and a master's degree in hold on, I'm getting confused here. A master's degree in fisheries and wildlife services from Virginia Tech. I used to live in Roanoke. I didn't know that. Kate's work brings together science, stewardship, and community engagement to help people understand how healthy ecosystems benefit both wildlife and communities. So please join me in welcoming Kate Kelly.
Just a few slides about Lewis Creek Association and what we do. And then I'm going to turn it over to Kris, who's going to talk to you really the bulk of the presentation about salt. Okay, so Lewis Creek Association, as you know, we are a independent nonprofit watershed organization. We focus our work in our watershed towns, and we work with town conservation commissions like the Shelburne Natural Resources Conservation Commission, our state and local partners, and other groups to try to improve water quality, wildlife habitat, and other things. So as our name suggests, we do work in the Lewis Creek watershed, but we also work in the La Platte River watershed, which is where you sit tonight, and the direct to lake drainages. So these small little watersheds that drain directly out into Lake Champlain and Shelburne and Charlotte and down a little bit into Ferrisburgh. So one of the things that we have recognized over the years is that we need to address Lake Champlain's pollution, really. And one of those things that pollutes Lake Champlain is phosphorus. It's a nutrient that you may put as a fertilizer on your plants at home. And it's good for plants. It's required for plants to grow. But too much of it is a bad thing. And in the Lake Champlain watershed, we have too much phosphorus going into Lake Champlain, and we really need to clean it up. So we have created the Ahead of the Storm program, which is a series of demonstration sites throughout the watersheds that demonstrate the 3 S's. So these 3 principles of how we want to manage water: slow it down, spread it out, and sink it into the ground. I'm going to give an example of each one of these so you have sort of a feel for what the sites are and what these principles are. So slowing water down, this is a site along East Thompsons Point Road in Charlotte. This is a series of essentially rock check dams in a roadside swale. So we're kind of standing on the road looking down towards the stream. And these rock check dams slow the water down as it's heading down this ditch towards the stream. And in the process, the plants, here in between these areas can help use some of the nutrients in the water, soak them up, and clean the water up a little bit before it reaches the stream. Spreading water out. This is the Heinsberg Town Garage site, and I don't have a good photo right here in the presentation, but there was a berm right next to this stream, so a big mound of dirt. There were buildings right here next to the stream as well. And so our goal here is really to allow this stream to kind of spread out and flood onto its floodplain when it rains, when we have a big storm event. So we were able to get some funding to both move the buildings back. We built a new town garage up here. Dig out that old berm and some of the extra sediment that was there. Place some logs and rocks right in the stream itself, which maybe you can't really see there, but like right here, these big rock structures that you see. And then do this planting along the floodplain. So now when we get a big rain event like we did last year, the stream is able to spill out onto its floodplain and spread out, thereby, lowering the velocity of the water heading downstream and the infrastructure that's downstream, like the culvert that's on the road that I'm standing on. And then sinking water down into the ground. You guys probably all recognize this spot, Shelburne Community School. This is the bus circle. It used to be a big grassy mound, and the water went directly into storm grates, catch basins underground, into a pipe system, and from there, anyone want to guess? Yeah, directly into McCabe's Brook and into the lake. Didn't get cleaned up, didn't go to the stormwater treatment system. So we were able to get some grant funding to build these rain gardens in the grassy mound system. So now that water goes into these depressions, kind of soaks slowly into the ground. It gets cleaned up by the plants that are planted there, thanks to the kids in the at the school. So continue to do some maintenance work on the rain gardens there and clean that water up a little bit. So we have a story map on our website with all these sites if you want to explore more. I'm not going to go into a lot of detail tonight, but I will just mention that we have a new guidance manual too for landowners if you're interested in learning a little bit more about like how you might be able to use your own property or maybe your town property to help improve water quality. I have a copy of this that I have to pass around, but there are some copies as well on the back table if anyone wants to take a look. And you can access that on our website as well for free. Download a PDF. So I'll start that going around if you want to check it out. So all these things are great for cleaning up phosphorus out of the water. They help, again, take that sediment out, get the plants that are able to kind of clean that water up. But what that doesn't do is remove chloride from the water. So chloride is another pollutant that Kris is going to tell us a lot about here tonight. And we're really concerned about this because a lot of our watersheds do have increasing chloride levels. And so we wanted to invite an expert to really speak to us about what's going on with chloride and what we can all do to help improve our water quality as relates to chloride in our systems. So we partnered with the Shelburne Natural Resources Conservation Commission and the library here to bring in Kris Stepenuck. Kris is an associate director and extension leader for Lake Champlain Sea Grant, and she's an extension associate professor in the Rubenstein School of Environment and Natural Resources at UVM. She has for more than 20 years been collaborating with community members to understand and address the impacts of land use and a changing world on surface water bodies. Kris holds a PhD in environment and resources from the University of Wisconsin-Madison. And in her free time, she enjoys hiking, skiing, and bicycling as much as possible with her husband and chocolate lab. So with that, I will turn it over to Kris to talk to us a little bit more about.
Thank you, Kris. Great. So first thing up, we get chemistry. Ready? Who knows how salt does what it does for us to keep it from to keep the pavement from freezing? You know the science behind it? Yeah.
Exploring sodium chloride.
Right. Exactly.
There's the freezing.
Exactly. So the way I like to describe it, we've got water, our little Mickey Mouse H2O, and when water is wanting to form ice, the water molecules are trying to bond together. And as you said, when we put salt, which is often sodium chloride, the same thing we put on our tables, when it hits the water, which still has liquid water present, it breaks apart into sodium and chloride ions. And those ions get in between the water molecules. The way that I like to describe it is hockey. If you think about hockey players who are trying to fight and the referee gets in between them, our sodium and chloride ions are like the hockey referee in between the players, doesn't let them fight. The sodium and chloride ions don't let water molecules bond to one another to form ice. And so that is how it works to lower the freezing point of water. And it's true for other kinds of things as well. So sometimes magnesium chloride can be used or calcium chloride can be used to prevent ice formation from on the roads. But those two, actually, when the ions break apart, they form heat. And so those can be used at lower pavement temperatures than sodium chloride can. So one of the best practices that I'm going to talk about in a little while is that if our communities or private contractors or ourselves are using sodium chloride, we shouldn't use it when the pavement temperatures are colder than 15 degrees Fahrenheit, because after it gets colder than 15 degrees Fahrenheit, there's not very much liquid water still present. If you know, even if a few little microscopic amounts of liquid water, so it doesn't do a very good job. But calcium chloride and magnesium chloride make heat when they break apart, so they can be used down to lower pavement temperatures. Okay, so the first time salt was used to prevent ice formation or to lower the freezing point on highways was in New Hampshire. There was a test 1938, 1939 on I-95 down along the seacoast. And the first time it started to be used after that was a successful attempt was 1941 and also in New Hampshire. The way it used to work back then, a couple of guys would stand in the back of the truck with their salt bags, a big old funnel in the back of the truck. They would pour salt out through the funnel, and every mile the driver would honk. And so they could kind of estimate how many pounds per mile they were putting down. At the time, on all US roads, but it was in New Hampshire, about 5,000 tons of salt were used at that time. And we have not looked back since then. So we've got time on the bottom axis in 1975, jump forward 30 years or so. And then sorry, I didn't change it. It's million metric tons of salt. A metric ton is 2,200 pounds instead of 2,000 pounds. So basically, we've just had an increase of salt use across US roads over time. We're somewhere 23 to 25 million metric tons of salt per year on our US roads, whatever, any road in the United States at this point. That doesn't mean much, right, to most people. So I sat down and I said, okay, what happens? What does that actually mean in something we might be able to visualize? So I thought about salt trucks and the big ones that our communities have. So basically, if you fill up one of the big salt trucks and that takes a certain amount of salt, basically 25 million tons, and I've translated 23 million metric tons into 25 million regular tons, is a traffic jam of salt trucks from Burlington to Seattle, back to Burlington, and back to Glacier National Park. So every year, that's how much salt we're putting on our roads.
Wow.
No problem. So it is a problem, as you know, as you've seen, you've heard. It is a problem. So what ways is it problems? The work that I do focuses on the lake. So a lot of times it would be water quality, and my degrees are in water quality. So I'll talk about water quality, but other things as well. So one thing water quality wise is when you get too much salt, and we often are measuring this in the chloride part of the sodium chloride. So it can be toxic to fish. So let's see, they died. Okay, so fish, you have the same slide twice. I'm like, no, the fish died. And they turn upside down. So this is truly, I used to work in an aquatic toxicology lab. What we use as our death control was salt, because it can affect osmosis of fish and whatnot. So if in too high of concentrations, fish will die. At lower concentrations, it can just affect the reproduction. The eggs can't survive salty condition. So, but at higher levels, and if you would like to test your hand, I brought some samples from some streams around Chittenden County, and we can see if the fish would survive in those streams afterwards. But it can also affect the other parts of the food web, the aquatic insects or other life. It can also affect natural lake cycling. So the example that I'll give here comes from Mirror Lake, which is in Lake Placid. A normal lake would have ice in the winter, just like, yay, this winter. We've got on Lake Champlain, we've got our ice, and it comes spring when the ice melts, the water on top. So ice is floating. When ice melts, anybody know what the the water at the bottom, like you can see it on here, maybe you can't see it, that the densest water, the heaviest water is 4 degrees Celsius, around 39 degrees Fahrenheit, is sitting at the bottom of the lake. But when the ice melts in the spring, it actually gets heavier and it sinks. So what the effect is it does what's called turnover. So it should drop that water from the surface to the bottom, and at that moment, nutrients are released into the water. And it happens again in the summertime. There's stratification of temperature. If you've been swimming ever in the lake, your toes get cold, your arms are warm because the water is warmer on top. And in the fall, when the water gets cold, then we have another turnover when the cold water sinks to the bottom, and again, nutrients are released. That's what's supposed to happen. In Mirror Lake, and this is thanks to Brendan Wilsey for these slides, Mirror Lake, they salt a lot because it's Lake Placid, all the tourists are there, want to be safe. What happens with the salt shakers over there on the side, the salt sinks to the bottom because it's the most dense, and it creates a zone of anoxia without oxygen, so the fish can't be there. And what they have seen happen in the Mirror Lake is that turnover, that spring turnover that I just explained, actually does not happen, so that the whole lake doesn't get refreshed. It only happens above the salt wedge. So the fish, not that big of a deal in the winter, can't be in that bottom layer. They're somewhere up above that bottom layer. But when summer happens, do you know warm water or cold water, which one can hold more oxygen? Cold water. You're right on. And I used to use the example of soda. Nobody drinks soda anymore, but if you have a cold soda on the counter from the fridge, and a person has soda on the counter in the summertime, which one has more bubbles? The one in the fridge, because cold liquids can hold more gases. So true in lakes too. However, when it gets too warm, less oxygen at the surface, fish are getting squished into the middle. And as summer progresses, they get squished more and more. And this anoxic zone at the bottom hasn't gone away. So this is proven to be happening at times in Mirror Lake when because of salting. So other things that salt can do to our environment can kill vegetation along the roadsides, especially if people are using dried rock salt to put on the roads. It often will bounce off into the vegetation, so it can kill the vegetation. It will change soil microbes. Again, when it runs off or bounces off the pavement, it can compact soils. So another way that salt is used, and it's often actually calcium chloride, in our communities that have dirt roads in the summertime, it is used as a dust suppressant, and because it binds soil particles together. So in this case, our sodium chloride can cause compaction of soils, which means, to Kate's lesson at the beginning, we can't have as much infiltration. We can't sink water in as much because the soil is compacted. And it also can get into our groundwater, contaminating drinking water wells, as well as the drinking water sources, whether that's community or private. On the UVM campus, there was a lot of interest a couple of years ago because UVM was paying a lot of money due to infrastructure damages caused by salting. So these pictures are actually from an underground vault in the Davis Circle, where salt has come through from the surface and has formed stalactites from the surface, and it's corroding the metal within those structures. It's also corroding steps and doorways. And on the UVM campus, some of the doors are historic, so they have historic glass or carving, and they have the electronics for our key cards. So a single door can cost UVM $100,000 to replace. And so it's a big deal when your door that you've replaced only lasts half the life of what you would expect, or when your vaults are lasting half the time. So it's costing a lot of money from the UVM campus example. And also, of course, there's lawsuits on the other side of the coin. Liability is, I will tell you, the biggest driver when we talk to private contractors, when we talk to community road foremen. Liability is the number one thing that is driving people's decisions. They want to keep people safe, the people who are putting the salt out. Okay, so what's happening in Vermont with water quality? So I've got this is Lake Champlain, and each rectangle on that slide is a different tributary or different river or stream that's coming into Lake Champlain. And what I want you to focus on, so we've got the years on the bottom of each, and then it's always chloride on the vertical. So between 2010 and 2023 is like the right-hand side of each of these graphs. And you see that that line is going upward. So basically what that is showing is we are increasing chloride in our tributaries on average, for the data that have been collected. All the tributaries have increased in the last 15 years or so. And as Kate said, once we put chloride in, we don't have a good way of getting it out. We're just increasing. So in Lake Champlain itself, same axes. We've got time on the horizontal and chloride concentrations on the vertical. And if we go from 2010 over, we just see an increase in chloride buildup within Lake Champlain. It's still at levels that are low enough that are not problematic, but future people who are here are going to have to deal with what we have done. We also know this is a study that was done and was published, I think, in 2017, that lakes worldwide in northern climates, we are seeing, they looked at lakes compared to the road surface area and the area of land that drains to those lakes. And we see chloride concentrations increasing in lakes worldwide, including Lake Champlain was part of this study. So locally, I think Dana actually worked on this. The Sunnyside Brook is in Colchester. So the example here is looking at aquatic insects that are sensitive to pollution. And the species are mayflies, stoneflies, and caddisflies. Their scientific names are Ephemeroptera, Plecoptera, and Trichoptera, or EPT. So the biologists from the state Department of Environmental Conservation go out and they collect insects in the fall. And they looked at the number of different kinds of aquatic insects of these sensitive taxa. And they found back in 2002, things were good. They had 16 different kinds or aquatic species, which means that the stream was fully supporting aquatic life. When it came up to 2005, they had lost a species or taxa. 2006 and 2010, things looked a little bit worse. 2011, oh, maybe we got a rebound. And since 2011 and onward, things have just gone downhill. And it's not supporting aquatic life. That stream any longer is not supporting aquatic life. So how much chloride is too much chloride to have in our streams? So the Environmental Protection Agency, this is driven by the Clean Water Act, which from 1972 was when it was signed. Did research and looked at what research was available. And so they have a set, it's called an acute, let me go to the next slide. They have an acute standard of 860 milligrams per liter of chloride, which means that there could be death to the organisms at that level if you get to that concentration. A chronic level, again, this would be more long-term exposure. Fish eggs wouldn't survive at a level of 230 milligrams per liter. So you either have immediate death, 860 milligrams per liter, or long-term consequences to reproduction of fish or other aquatic life. I don't know what I just did because I pushed the wrong button. So let me see. Okay, there we go. Okay, so Sunnyside Brook, and Dana might have been collecting these data back here on this side,
That was 2013.
2013.
Those are graph samples. We were doing continuous.
Okay, all right.
Any data 2013?
Well, in the middle there are. So here's our 230 milligrams per liter. Here's our 860. So this is the reproductive impact. This is death. So back in 2006, our chloride levels were hovering around that impact in eggs and whatnot. And now when we get to 2021, we have moved up consistently into the zone of death to aquatic life. Again, just that one example. So this stream, Sunnyside Brook, has been listed as impaired for chloride, which means that now we have to come up with a plan of what do we do on the land that changes things, that makes it so it's not contaminated by chloride. And the state has worked on that. So just for a moment, I want to talk about other things. What other things can we put on the road that might actually help us to prevent ice from forming, that could also reduce the freezing point? So I used to live in Wisconsin, and they would try cheese waste, and that would work. But what happens, and maybe I'll do the other things first, because some of them have the same root things. Molasses have been used, sugars, or beet juice also. We used to have that in Wisconsin, we had purple roads. So those three things are sugars, and they work similarly to the way that the sodium chloride works. But when they would run off into a waterway, basically it's a party for the microbes because it's sugar. And so all these microbes are like, woohoo, sugar, and they reproduce, and they get, like, there's a lot of them, but then there's no more sugar because they've eaten it all, and then they die, and then they have to decompose, and decomposing takes oxygen. So there's what's called a biochemical oxygen demand, meaning that everything that's trying to decompose them sucks away all the oxygen, and then there's no oxygen left in the stream to keep the fish and other aquatic life alive, because we put all these sugars into the stream. So they have their own problems. Yes, they work to keep us safe on the roads, but they also do something bad in the stream. And then the top left is sand. So we could put sand on our roads. It doesn't prevent or reduce the freezing point, but what it does is provide traction for us on the surface of ice. And when it would run off into a waterway at the end of the season, it would potentially fill in between rocks in the bottom of the stream. And what fish will lay their eggs in that area, and usually they rely on upwelling of groundwater to help oxygenate the eggs. But if you put sand in between there, that blocks the bubbling up of oxygenated water. It can also irritate fish gills if there's just sediment in the water. It also moves phosphorus, because phosphorus sticks to sediment to move, or to soil to move. So sand has its own problems as well. So the cool part is that there are sustainable salting practices that we as individuals or our communities or private contractors can use that can actually reduce salt by 50%. Without trying all that hard, and still keep us safe, which is the best part. So one example, won't show you a video tonight, but we have a video on our website of community of Hyde Park has reduced their salt use by about 40% because they've adopted a few different practices, and we'll talk about those. So Dana Allen, who's a principal at Food State Consulting, and last year, I guess it was just last year, we talked with road foremen from around Chittenden County and asked them about what practices they're using for road salting to get a baseline of where we're at, and to be able to tell some success stories. Because one of the things we've learned in other research is that the road crews, whether that's private contractors or municipal, they learn really well from one another in that hearing success stories and hearing challenges and failures, or and being able to swap stories. And so one of the goals of us talking with them was to try to collect what we're doing, have a baseline. And so we created a story map of, well, Dana created the story map. I did the talking, Dana did the creating. So we wanted to share the story map with you. The question I have is, can we get on the internet?
Yes.
We got on. Okay. So Dana, I'm going to turn it to you to show the story.
Don't make me do the part where I make the laptop talk to the screen and the share.
I'll try.
This is always the recipe for a narrative.
So the highlights, we talked to 11 of the communities in Chittenden County, and I looked up the Shelburne. So Shelburne is managing 50 miles of paved roads, 20 miles of sidewalks, and they use between 1,000 and 1,200 tons a year of salt, and it's around 450 pounds per lane mile. I'll give you some comparisons in the.
That looks right.
Yes, good.
You were doing it.
All right, so now
Now
we
we
just gotta
just put it on
share.
the screen.
Yeah, right, so I think I probably have to stop the present.
Yes, probably.
We'll just go back to Teams.
Drag over.
Yeah. And sorry, it's gonna take a second.
No, it's better you than me. I'm elder millennial, so I can't do this anymore. It's over for me.
Same age damage.
But
Yeah.
I think technologically and generationally.
No, that didn't do it.
Drag it, is it mirroring?
I think it's because of.
Yeah,
sharing.
yes, yes.
Yeah, it's to go.
Oh, there you
oh,
go.
you
There
got
it
you got
is. Okay, wait, we gotta
You're
bring it the
doing
rest of the way over.
It's like-
Oh, that's what it is.
Yes. Look
This
at that.
is so amazing.
Oh, God.
We're cracking.
Okay, hang on. Sorry.
Yeah, now you're gonna make me do mouse on the screen like this.
Okay, sorry. Yeah, no, you can't see anything.
No,
Sorry.
it's great. You 100% have this. So I'm gonna move this very carefully so that maybe I can do this correctly. So we made a story map. And why do we make a story map? Because they're more engaging than a report, or sometimes more engaging than a PowerPoint, but Chris's PowerPoint is surprisingly engaging. So that's really nice. But anyway, Kris did all the actual hard work of talking to the road foreman, and then I just got to put this together in a format that's somewhat easily understood by the public and super accessible, and that's what I like about these things. So what we have here is the first tab that you'll see up here is the actual story map. But then rather than just point out problems, because that's mostly what I've been doing in my consulting career with SALT, is pointing out problems. Kris actually put together a bunch of PDFs. So now I'm going to work a little backwards of solutions. And so we put those on this page here. And so we've basically got a bunch of 2-pagers about various different sustainable road salting practices. And so we've integrated some data and some management practices in the story map, and then these 2-pagers that anyone can access. So road crews can see them, you guys can see them, conservation commissions, etc. What I really like about this is this whole thing is solution oriented, sort of presenting an optimistic viewpoint of like, what can you do? Not just like, this is how bad the problems are. So those are all on there. We've got some different things: adjusting salt, brine solutions, calibration, pre-wetting at the spinner. What is it? RWIS stands for Road Weather Information Station. Yeah, I messed that up like every time we wrote it. But anyway, those are all on there. But then to just kind of look at the story map real quick, if it reloads, basically you can just kind of scroll through and you can see all this information. I wonder if we just wanted to put together some basic geodata for Chittenden County. Like, what are we talking about here? What is the problem? We've got over 1,200 miles of roads within Chittenden County. They maintain a bunch of different types of roads, whether it's paved. There's some gravel roads within Chittenden County. And so basically, as you scroll through, you get to see all this stuff. We also can see the sidewalk and bike path and recreation path network. Another thing I like about this, just because I'm a nerd with this sort of thing, is like these maps are interactive. And so if you want to zoom into your community, you can do that. You can zoom in, you can pan around, you can see exactly, all right, what has Shelburne got for, shared use paths and bike paths and things like that. What's the community actually maintaining here? So you can see all this stuff on this map. So that's kind of why we put this together, is to give you some options to see what's going on. And then this is really where Kris kind of put together a lot of data. And then I just kind of slapped together some charts and put them up here. But there's a ton of data on this website as far as like various road salting practices, usage by community. We anonymized this. So if you're looking for Shelburne, you're not going to find it. We did want to anonymize this. This isn't a shame exercise. This is actually like, all right, what are we as a community doing? But it gives you a sense of like, okay, where are these communities falling as far as like total annual amount used globally? So, and then one of the more interesting things I like about this particular map is like these sustainable salting practices used. And these were yes, no questions basically, to see what people are actually doing right now, right? So like, we wanted to establish a baseline for who is actually using some of these practices and who could potentially adopt some of these practices. So if a community isn't using something like segmented plows, that's an opportunity for them to start using segmented plows. Segmented plows conform to the road surface better, so they scrape it off, resulting in less salt used, potentially. So this gives us a baseline for that information. Again, this is anonymized, but it gives you, the public, a sense of like, all right, what are we doing already and what aren't we doing? So it looks like everyone is adjusting application rate, right? We've all got that ability. but we're not using anti-icing. And actually, this was sort of shocking. No one is using those road weather information stations. So,
Tell them there.
oh yeah, well, you know better than I do.
So
Yeah, you tell
yeah, so basically what they are WIS is the acronym there. That's why we can't say the words because we never do. It's basically they're just cameras and they can also have associated data collection for pavement temperature or dew point or precipitation happening. The simple ones are, I think, just a camera alone. And we know from the community of Peru, New York, when they install the cameras, it saved them about $15,000 a year in cost because what they had to do before installing the cameras was drive around and look at what the conditions were like. So it was staff time, just driving the roads. And now they can look at on their phones and they can look at the road condition with a $2,000 camera and they can answer that question without spending all the time that they were spending.
Yeah.
So it's a cheap investment for a community to save time, and to know something that's happening on the ground, whether they need to be plowing.
Yeah, it's one of those paradigm shifts that we're seeing over in like upstate New York, we haven't seen here yet. So if we're looking for opportunities to help people, like this is one of those good ones where it's like, hey, try this, it can save you a lot of time and money. And so then, there's a ton of different data here. I'm not gonna go through all of it unless you don't.
That's fine.
This was like
We
the
can give
conference
you
stuff.
the address if you wanna peruse it later. That's the idea, is we give you a hint and you can go check it out later on.
Yeah, so anyway, at the end, we got some key findings, we embedded some videos. I really like this part of it. This is one of the things I like with story maps. Like, obviously, it's not just like text heavy. We can embed interactive content like these videos and actually get stories from some of these road foremen that Kris was able to produce. I think that was a different project, right? Another Sea Grant project.
Yes.
But honestly, this is really important because like these people are talking to each other. These are peers talking to peers. And so like that's going to increase adoption probably of some of these practices, right? Like nerds like me coming in and being like, you guys should be doing this. They're like, what do you know about driving a dump truck? And the answer is nothing. But if they see another person who actually does know something about that, who's like, yeah, this worked for us and we saved tens of thousands of dollars, that has impact. So this is just an attempt at like getting that information out there. I think that's pretty much it. Yeah, public education, all the findings. So yeah, again, we can share this. I'm sure there's a list, email list, something.
Sign up on our list batch and we'll get you an email. There's a send us in the back.
I also have printouts of all of the fact sheets that Dana showed. They're in the back, so if you want paper, they're here.
Oh, and also I'll put in a plug for Kate and the Street Association. We're building a story map for their water quality data. So you can see all the annual sampling on the story map, which still editing.
Very, very soon.
Yeah, we don't see
Go
the back.
back to the part.
Yeah,
Okay.
Oh, gosh, yeah.
If I know how to do
Someone
that.
else, yeah. No, you did great before, so I'm not gonna touch anything right now.
Let me get my mouse back. Yes, there's.
So we want to give you a little bit more detail about these different practices that the communities can use, but also while Kate is getting this back, there are things that you can do. So if you are salting at home or you know somebody who salts, things that we can do as individuals. I have 3 main tips that I try to give both to the municipalities and as well as to us. Always shovel first or get the snow off first. We don't want to salt through snow because you'll need more salt to do that. So shovel first. And when you do put your salt down, we have a suggested spread pattern of 3 inches between the salt grains. And that's because you don't need piles of salt to do the work to keep the water from freezing. The salt grains can be about 3 inches apart. On the table in the back, I have some stickers that are 3 inches wide to give you that visual, and you're welcome to those. And then if you do end up with a pile of salt, sweep it up. Have a bucket in your garage or somewhere and use it for a different storm, because it doesn't need to just be there and then run off into the vegetation or the soils or the water. You can use it later on. There are other things you can do as well, but those are kind of the base things. from the community standpoint, just to give a perspective of what things are that our communities can do, they can calibrate their equipment. And basically what that means is they know how much salt is coming down the chute when they adjust a knob inside the cab of the vehicle. We know in Chittenden County that 89% of our communities are calibrating, which is great. They don't know how much is going out. That's not good. Dana just mentioned segmented plows. So cool new thing. These are all separate pieces. And the pieces actually operate separate from one another. So on our bumpy roads with potholes, these segmented plows can scrape the road better. South Burlington also has what they call, it's a secondary plow right here. It's called Adam that calls it a salt saver. He actually thinks that that second plow does an even better job than the segmented pieces. And we know that about 60% of our Chittenden County communities have bought into one or the other. I think South Burlington's the only one with the secondary. Everybody else has the segmented plows. But these are things that we as at our town meetings can support our communities to invest in so that they can adopt new technologies. The other thing that from their perspective, it's lighter, better for their backs to replace a piece of plow than an entire plow. Less potential for injury from their perspectives of fixing things over time. They can also track salt use. So there's some pretty cool in cab devices that they can have, and they'll know exactly for any given moment on their entire route how much salt is going out at that time. Just over half of the communities in Chittenden County have this capability at this time to know how much salt is going out. Dana also mentioned this pre-wetting salt spinner. So what that means, they literally have a thing that spins on the bottom of the center of the truck or sometimes at the back. That's the spinner. Salt comes down a chute, hits the spinner, and what they can do is wet the salt right before it hits the ground, and that makes it stay in place better on the road where we want it to do the work. There's been some tests done, and it's about 72% better, and it stays in place where you want it than if you just put dry salt on the road, because that just bounces off and goes away. So communities in Hyde Park is one that's doing this. As well as Winooski has adopted this. They put a saltwater mixture onto the salt. They can't use regular water because it would freeze up in the hoses, but saltwater. So most of our communities are not doing this. 64% of our Chittenden County communities are not pre-wetting. They can also measure pavement temperatures, and this goes back to, we know when the pavement is colder than 15 degrees, we don't want to use sodium chloride at all. And on the other side of that, if in the truck, the guys know that the pavement is already warmer than 32 degrees and it's sunny and it's going to be a nice warm day, then they can stop and not salt at all on that run. And that has saved Hyde Park a lot of times and not even having to put salt down. So we have about 50-50. Yes.
Just a detailed question. What's going on?
So basically, he's just adjusting. I think he's just trying to show the camera. But this is a sensor that reads, it's an infrared thermometer. So I don't know what he's doing with it, but it's an infrared thermometer. So in the truck, they just see temperature and it changes like as they drive. It changes digitally for them, but it's reading infrared or sending an infrared light onto the road. And then these road weather information stations. So these the cameras on the handouts that I have in the back or that are on the story map. I looked up costs for each of these things. So like for a community deciding about if they want to invest, you can see what the investment cost is. And again, these ones are pretty cheap in terms of a community budget, pretty cheap to think about. Anti-icing, what that is putting a salt water mixture on the road or the sidewalk before the storm hits. And you can see the stripes on the sidewalk here. What that does is it prevents the bond from forming between the ice and snow and the pavement. So it's the same thing as if you put oil in a frying pan before you fry an egg. You don't want your egg to stick to the pan, so you put oil in advance. This saltwater mixture, it activates the surface so that so that the ice is not going to stick to it, and then they can plow more easily. A clean surface is gonna take less salt to get to preventing ice formation. So I also asked, kind of what are their top motivations to reduce salt? So basically pink means, that reducing whatever this thing here is a kind of a big motivator. So the number one motivator is reducing environmental impacts. I think that's because they were talking to me and they knew that's what I do. Probably biased, so ignore that one. Reducing human health impacts, people don't want to pollute the water. They want to do the right thing for all of us. Reducing costs, just over half people said this is a pretty big deal to them. If we can reduce the cost and not use as much salt, 50% reduction in salt use is 50% cost savings. People are open to being recognized for using sustainable practices. Just over half of communities were pretty on board with that. And then less people are thinking around reducing infrastructure impacts, probably because using any salt, you're still getting some infrastructure impacts. So it's less buy-in there. The barriers, as I told you earlier, the number one barrier is liability concerns. We work in a litigious society, so 60% of people said this is a big deal. We don't want to be sued. Public opinion is kind of split. A third of people said that it's a pretty big deal. A third of people said it's somewhat of a deal. I feel like my conversations, it's kind of a big deal in communities because people tell their road foreman what they think about the road being whichever way it is, good or bad. They hear about it. People in these communities have, this one is, it's a bit funny to interpret. There's very good municipal leader support for the road foreman to make the right decisions for their communities. So that, and then alternatives, they don't know what to use if we don't use salt, because like I said, the examples, there's other things that we could use, but they have their own problems and then they might cost more. So key findings, the road foremen care so much about our safety, and we're privileged to have that. They realize that the public needs to understand kind of what they do, which is one of the reasons that this presentation exists, and trying to help us understand, that they can use less or that we can use less and still be safe. We need to have funding to be able to support new technologies, or that the communities would appreciate that, to be able to adopt some of these new practices. They have, and they appreciate the community leader support that they have. And one of the things that I would say is true is everybody is short-handed. And so not additional staff training is supported. And that is because there's turnover and people are always needing to bring in new people who need to understand kind of what they need to do to protect the environment and help keep us safe as well. So this is where the map is at, this go.uvm.edu. Dana, Kris, I think I'm going back to Kate. Yeah,
Great. Okay, so I won't keep us very long, although I think we're doing okay on time, but yes, we have this person right here in our room with us. She is famous. She's a famous water quality sampler, and I can't figure out how to get to my slide, so we're just gonna talk. Okay, so one of the things that we do is we monitor water quality in our local streams and rivers. And as Dana mentioned, we have a lovely story map that he also puts together for us on our website, which you can access here. That shows our last about 4 years of water quality data, sampling data in Lewis Creek and La Platte and direct to lake drainages. It looks something like this. I'm not going to go into all the details, but the idea is you can read about each of the things that we sample for, which is phosphorus, nitrogen, and chloride. You can see points on the map in different sizes that sort of give you an idea of like, is this a lot or a little? You can click on it and see additional information, any of those sampling points. But tonight, again, I just wanted to focus quickly on chloride, and this is just 1 year's worth of data. So this is what we did where we sampled last year, 2025. So I want to draw your attention to, I'm going to show you 3 different graphs. This is Lewis Creek. And the scale here along the y-axis goes from 0 to 14 milligrams per liter. So not a huge amount when we're talking about the 230 that is the chronic standard for the 860 that is the acute standard. So most of our sites in the Lewis Creek watershed, not huge amounts of chloride. Okay, now we move to, this is tributaries to Thorpe Brook. So this is one of the small direct to lake drainages in sort of Charlotte, like lower Charlotte area. It drains out into Town Farm Bay, that vicinity. So now our scale is 0 to 30. So we've got a few higher points. This is along Thompson's Point Road, this sort of orangey colored dot here. Again, not anywhere near the 230, but a little bit higher than most of our Lewis Creek sites. And then we get to the Little Platte River tributaries. So we don't sample, or we didn't sample last year directly in the Little Platte River, but we did sample in several areas that were around Little Platte. And you can see here, we now have 0 to 600. Okay, so we have something going on here. This red line that you're looking at is 230. So that's that chronic standard where there's a good chance that this is going to impact aquatic life. And you can see a few dots, these sort of light blue dots that are above that red line. Okay, so where is that light blue site? And some of those others, I'll just go back for a second. There are a few others here that are also quite high. They don't quite go above the red line, but also quite high. Okay, so we are here in Shelburne. See if I can figure out where we are right now. We're somewhere off the map at the north end of that screen. But this is the Shelburne Cemetery and the post office right here. And we sampled 3 sites along one of those streams. So you can kind of see the blue line. This is sort of the Marset Road down here and this neighborhood. 3 sites along that stream, and then 1 at sort of along the edge of the woods just east of the post office. So if you can picture where that little drainage goes in, both of those drain east into the La Platte River. So the really high one that we were looking at is that site by the post office area, that one red star. The rest of those also were elevated, but not quite as high as that one close to the post office. Just wanted to give you a feel for kind of like where those were and what you're looking at. The little blue dots on the screen, so this is all the same area. Little blue dots are actually like catch basins and culverts. So you can kind of see that a lot of these blue dots here in this neighborhood actually do drain out into that stream. And some of Falls Road and those catch basins end up draining into that tributary near the post office that runs down into the creek.
And what is that stream?
Neither of those are named, so they're just tributaries to the La Platte. So again, you know, some concerning values here, that, you know, we are, you know, this was a little bit of a surprise to us, honestly. I mean, these are fairly small streams, but they do have, fairly high numbers, and we would like to, you know, keep addressing that as best we can. As I mentioned, we do a lot of work with some of the other nutrients like phosphorus, and do the sampling for chloride as well. So we look forward to continuing to work with, you know, our communities and folks like you guys to give us expert ideas on how to reduce our chloride use and improve our quality of our waters. So, yeah.
Do you know if those were town roads that were plowed and salted, or are they home ownership
Right.
areas?
Good question. Yeah, I think all of those are town roads in that neighborhood that are, yeah. But post office obviously is not.
I'm sorry,
Yeah.
would you finish the sentence you said right there?
Post office is not a town to maintain.
So the post office, you're seeing a lot of chloride, is that what you're saying?
In that stream rate that runs sort of down past drainage area, I guess we could call it, and runs past.
And
the
so you
post
think
office.
that's due to salt being put on the post office parking lot?
Probably contributes to it, but also there are those catch basins along like Falls Road and some of that neighborhood area that drain into that same vicinity, that same stream.
So there's a lot of runoff coming down from that between Route 7 and Falls Road towards the post office.
Yeah, I don't, you're right, I don't know, I don't have the exact drainage boundaries of like where exactly all that is, but yeah, there are some pretty high values in there. Okay, so do you guys want to come back up and take questions too? I think that's all we have, but.
Sure. Did you collect statistics on like, or do any kind of research about how insurance companies deal with this? And so we are looking at, wanting to keep people safe. But mostly what we're looking at is we don't want to get sued.
Yeah.
Right? So it's like one thing is people might fall or they might slip.
Yeah.
And, is there any attempt to address the policy issues around how insurance companies are just really driving us broke?
Yeah, are you a plant? There's a bill in the legislature
Yeah.
right now, and it's about that, actually. And so it passed the Senate maybe a week and a half ago, something like that, and it's moving to the House. And what it is the voluntary training program, a voluntary program that private contractors, municipalities, and I'm not sure if municipalities were pulled out of it, actually. It might have been, it could be both, we'll say it's both for the moment, they were both in it. Would be trained and would understand practices like I just was talking about. And they would track their salt use. And in exchange for being trained and tracking salt use and using these best practices, they would experience or have the opportunity to have reduced liability exposure. And it's modeled after the state of New Hampshire has the same program. They call it the Green Snow Pro program. And they have had success with private contractors keeping records, having a slip and fall lawsuit come up. They produce the records, the lawsuit is not carried through or whatnot. So there is anecdotal evidence that it works in New Hampshire. I think were questions. The bill that is in Vermont right now went through legislature last year. And I think that was one of the questions that was kind of out there is would that actually work? And I think there are questions about whether it would work here or not to reduce liability risk. And the jury is still out. The bill hasn't passed officially, but that is a question that is out there for sure.
The fact that this is being discussed now on any level, though, at the legislative level in Vermont, is a huge sea change. When I started working on chloride in like 14 or 15 or whatever it was, we were meeting with state DC staff. And they were like, this is the thing we want, right? Because reduced application is really the only solution to elevated fluoride levels in waterways. Like you can't filter it out unless you're doing reverse osmosis, or whatever, that's not gonna happen. So that was the lever, that was the thing that they did. And so here we are 13 years later, 10 years, or whatever, now we're actually talking about it. So it's huge, it's honestly it's hard to state how big that is, and they're actually talking about it, whether or not it passes. Just that it's gotten to that level, there's an awareness there, so that's encouraging. So
Has there been any statistics though that that of how many suits there have been?
That's a good.
So
Yeah.
are the rise in the amount of salt, is that due to the fact that there's been a lot more suits, or we have a lot more roads? So there's two factors that might be driving that.
Yeah, good point.
And
And I don't know of research, but I'm mentally writing it down because it's a great research project.
Okay.
Yeah.
Well, the thing with so roads is one question, right? But I think your slide showed earlier, it's 6% increase in road surface, but a 43% increase in salt usage.
Yes.
And so the thing that's not fully captured in that is parking lots and, sidewalks and things like that. And I think so what I started finding years ago is that so we have three levels of this in a way, right? It's V-Trans, municipalities, private contractors, private residents. And V-Trans has been on sort of salt reduction for a while because they're just increasing margin, it's expensive. So they want to save money. So then the munis adopt it, right? So now that's what we're seeing here. So they're starting to change And then it's the private contractors, right? Like so they don't have the same like wherewithal maybe to like look at some of this research that municipalities do. So they're on, like, private services are honestly one of the larger contributors, both because there's a lot of parking lots, right? There's massive amounts of parking lots, they're all closed drainage systems, et cetera, they flow directly to waterways oftentimes. Like Sunnyside Brook is great because that's like Colchester area. So it's like Costco and all of those stores, or not to call out Costco, like all of those stores in that area. And that area is developed massively. It used to be wetlands primarily. That's parking lots. So like, you know, this sort of legislation really helps those guys, like those people figure this out. Cause yeah, otherwise they're just spreading salt out of fear.
Yeah.
Well, they also,
Fair enough.
they take their marching orders from businesses that are afraid of the lawsuits.
Right.
So they're being told to do it, and I know that's true, because I talked to some of the businesses that are making those orders, and they say, we are not changing our orders, they're gonna remain to salt it as much as you can.
I think that the salt, sorry, it gets thrown, also people confuse it with traction.
Yeah,
And they think, oh, we had to cover all of this with sand and
Yeah,
how to see
that's a
this
good
mud,
point.
or people aren't gonna slip on the granules.
yeah,
And that's something that I think.
It's a great point. yeah, you had a question? Yeah, yeah.
Matt Whitten with Addison County Road Watch. So are there other gatherings of foremen, road foremen that you're kind of thinking that you might make happen?
To have them
That you-
come together, so,
Yeah.
well, so a couple things, in Chittenden County, we are gonna do an end of season road foreman meeting, so that they can share with one another, and I know. For instance, Bolton has reduced their salt use by about 40% this winter, partially due to the salt shortage, they had to come up with kind of new plans, but they are also working with a different company that is using liquid products that have allowed them to reduce, and then Winooski has adopted the pre-wetting at the spinner and also anti-icing before the storm. And the calculations that Jason, who's the crew lead there, he thinks he's using a fifth of the salt. So they're gonna come together and share with one another of kind of what happened this winter. And then Dana and I have been talking about repeating the work that we did in Chittenden County in other counties so that we can talk.
That's what I'm getting
Yeah,
at,
yeah.
because
Yeah,
we have a stream in Middlebury,
Yeah.
Orange Brook, that's got really high elevated,
Should we
it's
come
similar to what you found near the post office.
Addison County.
Yeah, that's
Okay, all
kind
right, yeah, no, so I'm putting it, like, we're gonna do that.
Middlebury's our shire town,
Yeah.
and we've
Yeah.
got this one stream, and I think probably there are other streams in town that are similar.
Yeah,
And
yeah,
we would like to start to move toward
I would,
reducing
yeah.
what's being
Yeah,
used.
I'm happy to chat with mostly it's guys, I'll chat with the guys if they're willing to chat with me, and you'll make them during that, won't you? Yeah, and we've been doing annual trainings for all municipalities in Vermont or the Lake Champlain Basin of New York as well. With Hyde Park, so we have one October 7th in any Addison County communities that would want to come, and I'm also willing to host something more local. I just need a host, community.
We'll
We've
work
been
on it.
doing it in the highway garage, but we can,
Yeah, we're working on it.
so, yeah, we can make it happen. That would be great. I'd love to do it. Yes.
Two questions. One, with the training that you're talking about, is there a possibility that municipalities would open it up to some of the larger landscapers?
So they are welcome and we try to invite them. So I had a grad student in 2018 and we made a list, or he made the list, and then we did research with private contractors. So we have a list of, I don't know, 150 of them, but they change. That, you know, those people go in and out of business a lot, so my list is kind of out of date. And there are some that are on board already and have come, like we did one at a meeting in Stowe last year, not at Hyde Park, and we had several private contractors. So they are absolutely welcome, and I would love to include more in those conversations. And some of the videos we have are actually made in partnership with a private contracting company to show like how to do calibration on their trucks versus on the big trucks.
That's
So,
what I was gonna
yeah,
ask you
yeah,
next.
yeah.
The calibration equipment,
Yeah.
is that something that is adaptable to a larger contractor at least?
Yep.
That's not gonna cost.
Yep, nope, well, the calibration costs basically nothing, you need a bucket and a stopwatch, and, you just time how long it takes the salt to come out, and then, you have to adjust your equipment inside, so it costs nothing to do it. And we have the video, and then I also made a, so the thing with the private contractor trucks is it matters the spread, how far it spreads, how wide it spreads. So I created a calculator, based on their knobs within the truck of like what the spread distance is, so they can take their calibration, and then they can take their knob, speed, and they can put the two together and then know, at what knob, value to set it, to get it to go out at a certain rate. So there's a couple of things, on the website, not our story map, just the Lake Champlain Sea Grant website about road salt, which probably, I'm hoping is on, I have a card at the back that's about this size back there. That website is there, and I have a private contractor section of the website that has those calculators, as well as the videos we've made with these guys as well. Yeah, and we've also hosted, I didn't love it, I could host it again, a parking lot and sidewalk training for private contractors. It was online during COVID, so it could be done. So we can do it again, maybe in person.
And are you having one of the Chittenden County municipality meetings, did you say?
I'm gonna have all the road foremen are coming together on April 22nd to talk with one another. Yeah. Yes,
I'm just curious, is there resistance from people that make their money selling salt?
it's a good question. So I tried to get one of the distributors of salt to sponsor the salt education. They did not, but they didn't tell me no. They just said, we'll call you back later. They never called back. So I was like, they don't. But I haven't heard that, and one would think that would be, something. That said, I can't fully say that. Cargill is one of the distributors of salt, but Cargill also makes brine machines, which is what is needed to make the pre-wetting. So they have diversified themselves to be able to not go to business when we say we're using less salt. So I guess to be fair, they are also looking to see how technology is changing and adapting based on that, and selling different things that could be the new technologies. Yes.
When you, were talking about Winooski, you said they reduced their salt. But you mean they reduced it by 4/5, and they're using a fifth of what they?
That's what Jason thought. He did a calculation. He did an across the fence episode a couple weeks ago. And he had done calculations like the night before, and he's like, I think if I did the calculations right, I think we're using like a fifth of what we had been using, as a result. And so that was like part of the winter, right? Like calculating and who knows how many storms, but that's what he had come up with, is that he'd reduced it.
And isn't it Morton salt that has the slogan, when it rains, it pours?
That might be, yes.
So you
That
can
umbrella.
maybe use it when it snows, it pours?
Yeah, right, and we could do that, right? Yeah, yes.
Have you developed recommendations for individuals, or like at the micro level or neighborhood level?
Yeah.
I mean, I know you recommended tonight, but
Yeah, so those
do you have
three.
ideas for for raising awareness?
Yeah, so that is where's Sarah? Sarah and I are working on what it's called community-based social marketing, an approach to behavior change where you have a target audience and you want them to do something, and then you come up with a plan. So we are working on a community-based social marketing for that audience, and I have some things. We have somewhere in a bag at the back of the room, I have a pledge that people can sign if they want to, and in the pledge, there are a number of different things that one could do as an individual. We could wear traction devices on our feet, whether that's shoes or things you put over your shoes. We can shrink the area that we shovel in the winter at our homes, because we don't need to walk on that sidewalk in the winter, so we don't have to salt it. We can use electric mats, especially if we are people who have solar panels and we overproduce and we get a credit. You don't pay anything for your electric mats in the winter. So there's a bunch of different things that we can do to reduce salt, and they are, again, there's probably more they're not all here. They're all on paper.
Yeah. Great, that's great, because we could really use that.
Yeah, so happy to share that idea list, and then we hopefully will have in the next winter a campaign education for the public. Yes.
How about, have you, done any workshops with the schools? Cause I see phenomenal excess salt.
Well,
out of the schools,
Yeah. So Essex was, they had signed on to a grant with us, and it was such a good grant, we did get the money. But because of the schools, it was right at Sunnyside, was right in front of that. So the schools were, that particular school, by chance, was part of that grant. We didn't do it, we didn't get the grant, but the school was aware. But otherwise we haven't, and it's a good idea. And schools, I can tell you from my conversations with the road foreman in Chittenden County, that's one of the road foremen said, I'm pretty sure about half of the salt was used in the school.
Yeah.
Yeah.
That was the high school.
In the grant that we didn't get.
Yes, yeah, no, it was, right, that was the, and then
Yeah.
the Sunset, or, no, it's a different road.
Is it Indian?
Indian Brook.
Confused Indian
Yeah,
Brook, yeah.
Indian Brook, also
Anyway, a
high.
great idea to, the schools is certainly a place, and it's liability driven, as well. There was a question behind you, yes. Yeah, you,
Yeah, so I'm at the State House on the House Transportation Committee, and for V-Trans, I mean, I think over the last years, they've gotten the technology now, and they kind of understand it. But, you know, we recently, had one of the, V-Trans guys say, it's really getting down to, behavior of the workers, and just like, if you've just used 2/3 of a truck of sand and you're done, you know, don't empty the truck on your way down.
exactly.
Done with that, right, so,
Yep.
and that was good to hear. I mean, I think, you know, they kind of are keeping up with the technology, and they have all this technology
Yeah.
in the truck.
Yep, they do, yeah.
But then on the other piece, there's testimony for private contractors that liability is a big issue, whether it's the stores or whatever.
Yeah,
And salt is cheap compared to losses.
that's right. That's right.
And, you know, I thought the concept coming out of New Hampshire is a good one. We'll see how it goes. There is a lot of issues with trying to get agreement on things.
Yeah,
But, you know, if they were to sign up for best practices and record keeping to then really significantly reduce their liability chances.
yeah.
And I'll just tell a quick little story. Years ago, I was on jury duty, and somebody was suing the UVM because they slipped on ice. And their defense basically was pulling up this guy. All he does is salts sidewalks every day in the winter. That's all he does. And they said, well, what were you doing that day? What were you doing, you know? And in the end, he was an expert in how to keep the sidewalks clear.
Absolutely.
And, you know, so the lawsuit didn't go anywhere because people believed they were doing the absolute best they could.
Yep.
Yep. And, you know, contractors, I think, you know, just put the salt out there so everybody knows we're doing it.
That's right.
And,
Yeah.
yeah.
Yeah, for sure. Great points. Thanks for sharing all that. I feel like I have 3 different thoughts that all have just gone. One thing about the private contractors that I've heard from the private contractors with these new technologies, these are small businesses. They can't do it all. And so they're like, maybe I want to use the wedding, but I can't afford the whole setup for that. So I gotta figure this out too. If anybody has ideas, I need to start a business, or somebody needs to start a business that sells the brine to the private contractors, like gasoline style. So they can come in and fill up the brine, and they don't have to run their own brine system. And there's a disconnect between the municipalities and the private contractors. The municipalities often will barter with each other or share things or allow each other to come in, but with a private contractor, they can't be there all day, like manning the brine tank. And so there's a disconnect between where brine is available right now and the ability of these private contractor companies to be able to access that. And they want to, but they need another business to buy from, to make it viable for them.
It's just, you're right by the mind.
Yeah.
What was the bill What, do you know the number or?
Can you answer that question?
No, I don't know. It was one that came out of the house last year.
Okay,
If
hold
you
on.
really
The
get it.
19,
I got it, it's S, well, the introduction goes S.218. There's 218.
thank you, 218, there we go.
I don't know if you're gonna be in your committee, so small.
It would come over, yes, if it comes out of the Senate. Although it may go to agriculture or, environmental committee.
But it's not, it hasn't arrived yet.
Not that I know. Right. But probably we would have a couple of committees that would have jurisdiction. Or have shot.
There's another question, I think.
Yes.
In relation to the brine solution and the pre-wetting of the salt, what is the response when you have mechanics and people who say that those are more corrosive to vehicles? than-
So there was a big thing, and so this is another thing that happens, the state doesn't really want to talk to the municipalities because the state got egg on their face probably 2007, that was before I lived here, I don't know. Because they were having this corrosive thing, and there was this whole big thing that happened, and the public hated the brine because it was more corrosive, and I believe what happened is there was some kind of additive at the time that made it stick more to the vehicles. And so that was the problem. So now the state is really like very quiet, right? They're like under the table hiding about what they're doing, and they don't even want to talk to the municipalities. They don't want to talk to anybody because that happened. But if it's just brine, if it's just salt and water, it's a 23.3% mixture of salt and water. That's exactly like when you put dry rock salt on the road, it's gonna mix with water and it's gonna make brine. So you're getting the same thing. So what is being used now is not any different than throwing the rock salt dry on the road. So there's not that extra additive in there to do anything. Yeah, good question.
Curiosity, the salt sheds that were built in Shelburne by the railroad,
This is his time.
was that salt for roads?
Yeah.
Oh, yeah.
It's the largest, I mean, it's the largest depot in Vermont. Yeah, I mean, it's intermodal transport. It comes in on the rails. That's where most of the communities, I think, in this part of the state get their salt. But like if it's getting spread in Chittenden County, Washington County, Addison County, like all over Franklin County, like it probably comes from right there. So,
There is, I know Hyde Park gets their salt out of Canada. Yeah, they did not have a salt shortage this winter. They're,
Do they pay a tariff?
sorry. Oh, that's a good question. Yeah. Good question.
blame
They didn't
Canada.
complain about it.
Always blame Canada.
Yeah.
So there was some mention about the same thing for like surface water quality, but have there been any comparison impacts the well?
This is like near and dear to my heart because we always talk about surface water when we talk about these issues and no one actually asks about the actual fate of these dissolved ions, which aren't really getting sequestered anywhere. So yeah, it ends up in groundwater. Is anyone doing meaningful groundwater sampling? Not really. So it's interesting, like, I did a lot of work on the salt sheds in Shelburne for many years, and we attempted to get at groundwater using some methods that were fine. But then if you pull the data from that particular facility, and they have groundwater monitoring wells, you can see in certain areas that it's absolutely getting into the groundwater to the point where, and this is like, this is their own data, so like, I'm not saying anything spurious. They actually moved a sampling point because the well that they were sampling was so high with chloride that they were like, well, that well is not good. So we'll move the well over here. So it's like 306 and 306A. And so it was like, you just look at the data over the course of 5 years and it's like, it just increases continuously. And I think the other thing that we're not seeing with like water sampling is the fact that like, when you have salt adjacent to transportation networks or parking lots or whatever, it stays resident in soils and leaches out over time with precipitation. And so then like, you think when you're monitoring surface waters that you're gonna see these massive spikes in the winter of chloride. When monitoring conductivity in streams, you think, okay, well, when it melts, or rains or whatever in the winter, that's when you're getting your highest levels. And what in fact you see is that you get your highest levels oftentimes in the summer during drought periods because you have less flow in streams. And then it's leaching out continuously as base flow. right? So whatever water's coming out of the ground, it's going in the stream, it's jacking the chloride levels within the stream, there's not a lot of dilution, there's no precip, no flow. Then you get a rainstorm and it decreases, and then it just ramps over time. So I don't know if there's any real legislation around like groundwater and, chloride contamination. It's mostly focused on surface waters. So, but yeah, it gets in there for sure. And it does, okay, so sorry, I know you were gonna, but then the other thing is like in New York, they've done some studies on basically like wells adjacent to transportation networks or parking lots where there's chloride applied, and like they're seeing that these wells are increasing in their chloride concentration, which then gets into old plumbing like lead plumbing and leaches heavy metals out of that old plumbing. So then it becomes this direct health hazard. So, and that's not something that's really being pushed. So, great question, really thorny issue. Department of Health actually did a study in 2011, 2016. Scylla Larson was the PI on it, and it was a really great study. They took all the well data for which they had any sort of water samples, like, people getting their wells tested, and looked at like chloride level. I think they looked at metals as well, and then they looked at proximity to roads. Fascinating and like really synoptic. Like 1,100 data points or something like that. So yeah, worth a read. Yeah. Or sorry, I don't know where to take it. Yeah.
Yes.
Yeah, is there any tracking or research being done on the amount of salt used in water treatment systems? I mean, I have one, I bring bags of salt, home, and it's directly injected into the groundwater.
Yeah,
Well,
we
and
should.
wastewater treatment plants do it too.
Well, wastewater treatment plants would be tracked community, but individuals, we don't have that data, those data.
Because I think
That's a good point, and that is
it's totally invisible.
absolutely, yeah, and I know in Wisconsin where I used to work, that's on people's mind there because everybody had a softener. And so for sure, that is something we should think about, but if it's going to a wastewater treatment plant, it depends if you're on septic. So if it's on
Right.
septic, that would be a different source. If it's going to a wastewater plant, it's gonna be sort of counted.
Yes,
Yes.
yes, talking about septic.
Yeah.
Septic,
that's a
yeah,
good
septic
point.
gets to that
Yeah.
fate of like,
Yeah.
where does it end up? It ends up in the groundwater.
Yeah.
Right, but it's kind of an invisible problem.
Yeah.
Well, I mean, maybe I missed it, but it'd be so good if there was a way for us to check on that out in the rural areas. It's going into the septic.
Yeah, well, I mean, well.
Wait,
I mean, if you would like to try your hand as scientists, I
Yeah.
can show you a tool that I have on the desk back there that costs maybe $70.
Yeah.
And you can measure conductivity of water just by dipping it in, and you can get an answer in a minute or less. The thing is, what you don't know is if it's chloride, but you could grab a water sample and send it to the lab. And chloride doesn't cost that much, $20 maybe, $20 or
Still, but I'm talking about testing the ground,
groundwater.
yeah,
Well, but
the
do you have a
soil, or
well?
whatever, around the
Do you have a
septic.
well?
Yeah.
You can test your well, if I just turn on your.
Yeah,
So you could test that,
actually, I think
way.
we've done that.
Yeah, and then otherwise it would be a piezometer, which is slightly more involved, but,
You could always make some sort of like monitoring well.
right,
That's,
exactly,
PVC and sand
Right.
and perforations.
right.
You can do it. I wanted to mention though, that with conductivity, so if you do choose to buy like a little, $70 handheld conductivity meter, there is a regression equation.
Have the printout.
You do with the
Yeah.
equation.
Yeah,
So you can turn it into a chloride concentration. It's a rough approximation, but
I don't know
it's,
if it works for groundwater though.
yeah, because they didn't sample,
Right, they
they sampled surface labs.
Right, I would go to the lab, and get chloride direct, because you don't know if there's other ions.
Right, and it breaks down at the far ends of the spectrum.
Yeah.
It's like,
Yeah.
Thanks.
Okay.
Thanks, everybody.
That was fun.